In this third lesson in our probability unit, we are going to look at experimental probability. The objective of the lesson is to calculate the experimental probability of an experiment as a percent, fraction, and decimal. A couple of key concepts when considering experimental probability. When we talk about an experiment, we're simply talking about a trial that can have varying or changing results. You've seen many examples of experiments in the previous two videos, such as flipping a coin, spinning a spinner, or rolling a die. When we talk about experimental probability, we're looking at the number of times an event occurs compared to the total number of trials. And like with theoretical probability, experimental probability can be written as a percent, decimal, or fraction. Because experimental probability is a comparison of the number of times an event occurs and the total number of trials, we can use a ratio to find the experimental probability. Our numerator is the number of occurrences, the number of times a certain thing happens. Over, or our denominator, is the number of total trials. So let's say we have a six-sided die. We conduct an experiment where we roll it 50 times and we calculate or keep track of what the result is in each of those 50 rolls. We put that data together in a bar graph. We want to calculate the experimental probability of rolling a 2. In other words, what percent of the time in our trials or experiment did a 2 occur? Well, the total number of trials is provided right in the word problem, 50 times. So total trials is 50. We look to our bar graph to find out how many times did we get a 2. And we can see in our bar graph, we got a 2 4 of the times. 4 out of the 50 times. If I wanted to change this into a decimal, it's a pretty equal or easy, as it's an equivalent ratio of 8 to 100. So 8/100ths, or 8% of the time, we got a 2. Now, if you remember from our previous video, we found that the theoretical probability of any number on a die is about 16.7%. We only got a single number, in this case a 2, 8% of the time. Our experimental probability is less than the theoretical probability. Well, the number of trials is pretty small. We will find that if we conducted more trials, we'd be getting closer to, in theory, the probability. Now we want you to try one. Let's say we run an experiment where we roll a die 300 times. We keep track of each roll and put it into a bar graph, and you can see that bar graph there. What is the experimental probability of rolling a 6? Pause the video while you're working this problem, and then press play when you want to check your work. You can see we had far more trials, 300 trials compared to the 50 trials, and you can see our percentage was closer to what, in theory, we thought would happen. I want you to try a second problem. Same experiment. We rolled the die 300 times. We kept track of what we rolled and put it into a bar graph. What is the experimental probability of rolling an odd number? In other words, what percent of the time did an odd number occur? Pause the video while you're working this problem, and then press play when you're ready to check your work. In those first cases, the number of trials was provided to us in the word problem. In some word problems, they won't tell us the number of trials. We need to use the data to figure that out. So let's say we flipped 2 coins and the results were shown, or are shown below. What is the experimental probability of flipping 2 tails? In other words, based on our experiment, what percentage of the time did we get 2 tails? Well, to find the total number of trials, we just need to add up our data, 2, 6, 3, and 1. We can find that we conducted our experiment a total number of 12 trials. Out of those 12 trials, we can see that we got tails, 1 time. So the experimental probability of flipping 2 tails was 1 out of 12 times. This roughly translates to about 8/100ths, or 8% of the time. Again, if we looked at our theoretical probability we found for this same experiment in our previous video, we would think that tails would happen 25% of the time, because 1 out of the 4 possible outcomes is tails. But because our number of trials is pretty low, our experimental probability was pretty low. If we conducted this experiment more than 12 times, we would find our percent would be getting closer to that 25%. Here's another problem for you to try where the number of trials is not stated in the word problem. You need to use the data to calculate. 2 coins are flipped and the results are shown below. What is the experimental probability of flipping 2 tails? Based on our data, what percent of the time did we get 2 tails? Pause the video while you're working this problem and then press play when you're ready to check your work. In this case, you can see we conducted far more trials and we're getting closer to that 25%. For the last 3 problems, we have conducted an experiment using a 5-part spinner. We calculated or kept track of the results into a bar graph. We want you to choose 3 different experimental probabilities of your choice. Make sure you list each one using probability notation of P, parentheses, and then write which choice you made in parentheses. For example, you could calculate the experimental probability that you spun a 3. You could calculate the experimental probabilities of spinning an odd number. Those are just 2 examples. We want you to come up with 3. Everybody might choose something different, so you won't see an answer for these 3 problems. So in today's video, we calculated the experimental probability of an experiment as a percent, fraction, and decimal. Until next time.